Yeah, good morning, everyone. Good morning. A, warm, a very warm welcome to all the dignitaries, resource persons, and participants. So, before we begin today's session, let me briefly present an overview of the past 4 days of our AICT ATAL 6 days faculty development program on big data and cloud computing, applications and trends. So during these 4 days, we had highly enriching and interactive session conducted by the eminent experts. So participants explored key topics such as big data fundamentals, cloud architecture, data storage, privacy and security, as well as emerging applications of data analytics in real world entity. So these sessions were both technical and theoretical and the hands-on session. Participants gain Participants gain the adept understanding of modern computing frameworks and research directions in the field. Now it is my great pleasure to introduce today's distinguished speaker, Dr. N. Srinivas Naik Garu, Associate Professor and Head of the Department of Computer Science and Engineering at IIIT Kurnool. So, Sir obtained his PhD and ME in Computer Science from the Usmania University of Hyderabad and his BE in Computer Science and Engineering from OU from Hyderabad. He has rich teaching and research experience in reputed institutions such as IIIT Kurnool and IIIT Naya Raipur. So, Sir's research interest includes big data, cloud computing, machine learning, deep learning, and image processing. So, Sir has several publications in these areas and is also co-inventor of a patent. So the title should be Smart Electricity Metering System and the Method thereof. So it will be granted in 2023. So we are truly honored to have him with us today. So sir, we look forward to your valuable insight and expert knowledge during this session. So now I take a great pleasure in inviting Dr. N. Srinivas Naik Sir Garu to address gathering and begin today's session. So sir, Srinivas Naik Sir Garu, please come on to the dais.
హలో ఓకే మైక్ ఓకే పనిచేస్తుంది ఓకే గుడ్ మార్నింగ్ ఎవ్రీవన్. Am I audible? So I'm seeing most of the students, right? How many faculty are here? Okay. So what is big data? Because this workshop mainly focuses on big data and cloud computing, right? Tell me what is big data? What do you know about big data? Huh? Speak loudly because we are having this is the fourth day, right? Fifth day, right? So what is big data? How do you define the big data? Am I audible? Please occupy these seats, na? Last benches. You can occupy front seats. Come fast, come fast. Why we are studying the big data concepts? What is the need of big data? Please sit here. Any one of you know why you came for this FDP? What exactly you have learned these many days, and what do you want to learn? So we make this as an interactive session, right? Understood. So do you know anything about big data? You don't know. So what is big data, right? So we are having our traditional systems, right? In the traditional systems, we are unable to store the data, right? We are unable to store the data and we are unable to process the data in a traditional way, right? Understood? So why we are using for big data? Because we want to when we are unable to store and process the data in a single system, right? We are moving towards a distributed environment, right? In a distributed environment, what exactly we are doing? So we have to find out how we are going to store this big data, how we are going to process this big data, and how we are going to analyze this big data, right? So for this, we need to discuss about 5 E's, right? What are the 5 E's? What are the 5 E's that we need to discuss? Volume, velocity, variety, veracity, and value, right? So if you know about all these 5 E's, then you will understand what is big data and why you are studying big data, right? And what is volume here? What is the meaning of volume? What is the meaning of volume? What is volume? What is the general meaning of volume? Amount of data, right? So the huge amount of data. Suppose in earlier days when we were studying the BTech, we were having the CD drives, right? CD drives and DVD drives, right? But nowadays you are having the SSDs, right? Understood? SSDs and hard disk and pen drives which were having the capacity of more than terabytes, right? So what does it mean? You are having huge volumes of data, right? Understood? So if you see, everyone, can you see the PPTs? Can you see the slides? Yes, sir. So if you see here, the day by day the data is increasing exponentially, right? So how we are going to address the exponential data? How we are going to store the exponential data? So earlier the data is in gigabytes, then terabytes, petabytes, exabytes, right? Understood? What is the older model of what is the older generation of generating the data? In the earlier days, who is generating the data? Only few companies are generating the data, right? Can you see the slide? Is it visible? Only few companies are generating the data and we are consuming the data, right? But what is the new model? What is the new model? All of us are generating the data, right? All of us are generating the data and all of us are consuming the data. How exactly you are generating the data? How you are generating the data? How you are generating the data? You are having lots of examples, right? So some of the examples are through cyber networks and user tracking and engagement and social networks, e-commerce, right, and financial services and real-time search, right? So we are generating the data through various platforms. Understood? So if you see here, please be silent. Please listen here. So if you see here, this is the old statistics, right? So the around 18 terabytes of data is generating by the Twitter, right? And more than 35 terabytes of data which is generated by the Facebook, and Google is generating more than 50 terabytes of data, right? This data is around 3 to 4 years back data. Now the data is becoming double, right? Understood? So if you see the statistics, there are lots of data that is being generated through various sources. Understood? So now what we are having huge volumes of data, right? Now we are having huge volumes of data. Next, what is the way next? Next we will discuss about what are the different types of data that we are having, right? So what are the different types of data that we were having? Have you studied RDBMS? What kind of data it is? You have studied SQL. What kind of data it is? How you are going to store the data? Queries, right? So what does it mean? So if you are storing the data using some schema, right? You are following the particular schema to store the data and to process the data and to retrieve the data, right? So if you want to store and process and retrieve the data using the proper schema, then we will call such kind of data as a structured data. And we are having semi-structured data where you will access your emails and the XML files, right? What about unstructured data? What is unstructured data? What is unstructured data? So if you see, if you do not communicate, it is very difficult to deliver a lecture, right? Understood. So what is unstructured data? So what about images, video, audio files? What kind of data it is? Why we call this as unstructured data? It will have structure, right? Then why we are calling it as unstructured data? As I said, it won't follow a schema to store and process the data. Understood? So it is not following the schema. That's why we call it as a unstructured data, right? So if you see here, to extract the knowledge, right? So suppose if you are developing an application, what kind of data you require? Are you BTech final year? Third year? Okay. So in final year you will develop some project, right? Whenever you are developing a project, you will work on the project, right? What kind of data that you will work on? You will work on all kinds of data, right? So you will have the database as a end, right? End device, right? Understood? You will have the database where you will work on the structured data, and you may work on the text data or image data or audio data or video data, right? Understood? So what exactly you require to extract some information? You require all these kinds of data. Understood? So this is an example. This is a broad example. So for you to understand structured and unstructured data, right? So if you follow traditional approach, so we know the traditional approach, it will work only for the structured data, right? If you want to work on the unstructured data, so you cannot follow the traditional approach to work on the structured data, unstructured data, right? What does it mean? What is the meaning of this diagram? Can anyone tell what exactly we are referring here? What exactly we are referring here? So we are having one user, right? We are having one user. So he is having social media accounts, he is having gaming accounts, he is having entertainment accounts, he is having various accounts, right? So if you see, he is having various accounts, right? In these accounts, whether we are having only one type of data. If you see in the banking finance, right? Here mostly they will work on the structured data, right? Whereas entertainment, it will work on the unstructured data, right? So here a single user works on different types of data, right? If a single user works on different types of data, he is generating this much amount of different types of data. Then you think about millions and trillions of users, how much data that is being generated, and how many different types of data that we have. What is velocity? The third one is velocity, right? We are having volume, we have discussed variety, next velocity. What is velocity? Speed, right? What does it mean? So what does it mean in this context? What does it mean? The speed, the frequency at which the data is being generated, right? Understood? So the speed at which, why we require this velocity? Why we require this velocity? Why we require this velocity? How many of you play online games? No one will play. So you will have some online streaming data, right? Understood? So it requires the how much amount of data that is being generated, and what are the different types of data that is being generated, and how much speed the data is coming, right? Understood? From various sources. So this mostly useful for the making the analytical decisions, right? This speed will depends on how much data, means what kind of decision that you are going to make. So if you see here, how much data that is being generated per minute, right? Per day, right? So lots of data is being generated per day, right? If you see here, Google processes 20 petabytes of data, right? Like similarly Yahoo, eBay, right? So there are various types of, means different types of data, and how much speed the data is being generated by various companies. Understood? So if you see here, per minute, how much data that is being generated. Understood? This we'll discuss about here the velocity, how much speed the data is being coming, right? So per second, this much amount of data that is being generated, right? So here I mean to say that for every year the data is becoming double, right? Understood? So data is growing exponentially. So next, so we have discussed about volume, velocity, variety. Next we discuss about veracity. What is the meaning of veracity here? What is veracity? What is veracity? Huh? Speed. Velocity is different, veracity is different, right? Velocity is speed. Veracity, Veracity. Veracity. What is veracity here? Huh? Quality of the data, right? How much data? Suppose you are having huge volumes of data. If there is no quality, then what is the use of that data, right? Understood? You should have the quality of the data, right? Suppose if you don't have the quality of the data, then what will happen here? If you see here, these all are, if you see in these countries, in this continent, these are the various data that is the incorrect data that we are having, right? This is the incorrect data, right? What will happen if you have the incorrect data? What is the problem that if you have the incorrect data? Suppose you are having a company, right? You are generating lots of data, right? If that data is, suppose 30% of the data is incorrect, right? Then what is the problem that you will get? The end customer will not believe you, right? You will unable to generate the revenue out of it, right? Understood? So you should have the correct data, right? You should not have the inconsistent data, right? You should not have the inaccurate data. The data that which you have must be a complete data. Understood? So data here doesn't mean that we are only discussing about the quantity of the data, right? So here, along with the quantity, we need to discuss about the quality of the data. Understood? And what is the fifth way that we will discuss? We have discussed volume, velocity, variety, veracity, right? Next one is value, right? Suppose if you don't have the value in the big data, right, then why you are studying about big data, right? Or why you are having the big Hadoop clusters, right? If you are unable to generate anything out of it, right, you must generate some revenue out of the data that you are being generated or captured or processed, right? If you are unable to generate anything, right, then what will happen? There is no use of the data, right? If you are not generating any revenue out of it, then there is no use of the data. What is the meaning of value here? Value doesn't mean that only the revenue, right? The quality of the product, right? The quality and the meaningful data that you are giving to the end customer. Understood? So we'll learn these 5 E's with the help of one example. So assume that you are having the hospital, right? Assume that we are having the use case as the hospital, right? Can you tell me what is the 5 E's in this hospital? So if you see here, so what is the volume here? What is the volume in this case? What is the volume in the hospital? Patient data, right? The patient data, right? You are having n number of patients. The n number of patients are daily coming, right? So that data is being generated, right? Understood? What is the meaning of velocity here? What is the meaning of velocity? What is the meaning of velocity in this use case? So it is mentioned here, right? The patient records and the test results, right? So this kind of data will be taken care by the hospital management, right? And then we are having variety of data, right? What are the different types of data we will have in this hospital management? The X-ray images, right? And some of the video files, right? Some of the text documents, right? So some of the patient records and some of the test results in the form of text documents, right? So here we are having different types of data. Variety means here we are having different types of data, right? So what is the veracity here? What is the veracity means? What is the trustworthiness in the hospital? Why you are trusting the hospital, right? So because when you are getting the accurate results, right, when you are getting the accurate results are when the particular doctor is treating you accurately, right, and then when the particular doctor is treating you accurately, the trust will build between the doctor and the patient, right? Then automatically the hospital, the crowd will come to the hospital, right? Then what kind of value you are generating in the hospital? Anyway, revenue is there, right? Revenue is part of it. And other than revenue, what value you are generating here? The accurate identification of the disease and the better treatment. Understood? So these are the value when we take the use case of the hospital management. So why we are studying big data now, right? Why not earlier? Why we are studying the big data now? What was the earlier approach? What is the traditional approach that we are having? What is the traditional approach? What is the traditional approach here? Can you see this one? This is the application server, this is the database server, right? Okay. What is the traditional approach that we are having? Can you see any issues in this traditional approach? What is the issue in this traditional approach? What exactly we are doing here? The user is requesting the data to the application server, right? And what exactly the application server will do? It will run the logic, right? Whatever the program, whatever the query that you are written, that query will be executed in the application server, right? The application server will not contain any data. Where the data will be present? The data is there in the database server, right? Understood? The data is there in the database server. So from this database server, the data will come to the application server. Understood? And here the whatever the logic that you have written, whatever the query that you have written, based on the query, here the data will be processed and you will get the results back, and the remaining will be stored back to the database server. Understood? So what is the issue that you are identifying here? What is the issue that you are having here? What is the problem in this traditional approach? What is the problem in this traditional approach? Suppose if you sit for few hours, if you don't understand, it is waste of time for you and for me also, right? If you study for at least 1 hour, you should study, you should listen to the concepts, right? If you don't understand, you just ask me, right? I will try to explain. So what is the issue in this traditional approach? What is the issue? Here we are moving the data, right? Here we are moving the data to the logic, right? So what is happening here? Lot of time is spending on moving the data itself, right? If the data is in KB or MB, it's okay, right? But if your data is in GB or terabytes, right? So then lot of time will be spent on moving the data from database server to the application server. Understood? So then what is the big data approach? What is the solution that you can give? What is the solution? What is the solution? Instead of moving the data to the logic, right, we can move the logic to the data, right? Because whatever logic that you will write, it will be in kbs or at max in mbs, right? It will not be more than mbs, right? Understood? Whatever the code that you will write, right, it will not be more than mbs, right? So better to move the logic to the where exactly the data has been stored. Understood? So if you see here, if you see here, this is the master node, right? This is the master node where where we will split your data and it will distribute this data to the various nodes. We'll discuss this in detail. We'll distribute the data to various nodes, and then the logic, whatever the logic submitted by this user, right? This logic will be distributed to the nodes where exactly the data is present, right? Understood? Then, then what will happen here? What exactly we have done there? The data is distributed across the cluster and the logic that will run parallelly, right? The logic will run parallelly in all these data nodes, right? Then when you are having the parallel processing, what is the advantage that you will get? If you are having the parallel processing, what advantage you will get? So all of you are using some laptops, right? Everyone is having some laptops or desktops, right? So you are having the multi-core processor, right? You are having multi-core processor, na? Dual core or octa-core or hexa-core you are having, right? What is the advantage if you are having single core and hexa-core? Some benefit should be there, right? What is that benefit? If there is no benefit, then why you are buying the hexa-core processor? You can buy a single core or dual core processor, right? Understood? What is the benefit that you will get? Faster execution, right? When you run the task parallelly, you will get the faster execution. Understood? When you submit a job, you will get the results immediately, right? Depends on the amount of data that you have, right? Understood? And in each processor, you will have some threads, right? You will use some threads, right, in the processor. So the threads will be used for the parallel execution. How many of you have you done any deep learning project? Have you studied that machine learning or deep learning course? So what is the, do you know about GPU? GPU. What is GPU? So what it contains? What exactly GPU contains? What GPU contains? Number of cores, right? The number of cores will be in thousands, right? So because if you see in any deep learning application, mostly they will do the matrix multiplication, right? So for that you will require the number of cores should be more. So GPUs contains 1000 to 10,000 number of cores, right? Understood? So what are the applications of big data, right? If you don't have any applications of big data, then why you are studying big data, right? So we are having various applications of big data. What are the applications of big data? Healthcare, in healthcare, transportation, telecommunication, financial services, IT, retail industry. So if you take any kind of industry, right? So the big data will be used, right? So why the big data is used? Because you are having that we have discussed 5 V's, right? So those 5 V's will be used in each and every industry. Understood? So what are the challenges of big data? What are the challenges of big data? What challenges we have? So how you are going to store the data, right? How you are going to store the data that you are having, right? And next, once you store the data, how you are going to process the data, right? First challenge is storing the data. Next challenge is processing the data, right? And next challenge is maintaining the scalability. And next challenge is maintaining the data security, right? So if you see here, we are having monolithic approach and the distributed approach, right? So monolithic approach means what? The traditional approach where you are having one single server, right? What is the meaning of distributed approach? You are having thin clients which are distributed across the nodes as nodes in the cluster, right? If you see here, what is the scalability here? What is the meaning of scalability? So if you are having a monolithic approach, what kind of scalability you will have? You will have the vertical scaling, right? What does it mean? You can increase the number of cores, or you can increase the RAM size, you can increase the hard disk size. Understood? So that is vertical scaling, right? So that is called vertical scaling, right? Whereas in a distributed approach, we can follow vertical as well as the horizontal scaling. We can follow both, right? What is the meaning of horizontal scaling here? What is horizontal scaling? You are increasing the number of nodes, right? Assume that earlier you are having 100 nodes, right? After some point of time, based on your requirement, you need to increase another 20 or 30 or 40 or 50 nodes, right? That can be done, right? That we will call it as the horizontal scaling. What is the, we will discuss high availability, right? We will discuss high availability later. And what is cost effectiveness? If you are having a single server, right, it is costly, right? Whereas in the distributed approach, we are following the commodity hardware, right? We are not buying any expensive machines to build a cluster. We are having the commodity machines to build a cluster. So how many of you know about Google, right? What exactly Google is doing? Why Google is famous? Why Google is famous? Because of its search engine, right? The Google search engine is famous, right? So how exactly the Google search engine will work? How Google search engine will work? So if you see here, earlier days, Google used to use the traditional data servers, right? The monolithic approach that we have discussed, right? It has a lot of issues, right? What are the issues that it is having? Thousands of search queries were raised per second, right? And each query rate reads hundreds of megabytes of data, right? Means what? It takes lots of time, right? It takes lots of time to process the data if you are using the traditional servers, right? So that's why they have moved to the distributed environment, right? What is the distributed environment they have? Is the Google file system, right? Understood? Instead of having the traditional file system, they are having the n number of, like, they are having a data center, right? If you see in Visakhapatnam, recently they have announced that they are building a data center, right? What exactly the data center contains? What data center contains? This cluster only, right? The data center contains thousands of machines, right? Thousands of machines it contains, and on top of the thousands of machines, how you are going to store the data, right? And how you are going to process the data, right? So what were the challenges that we are facing? The single central storage is a challenge. What is the solution? Instead of going for the single storage, we are moving towards the distributed storage instead of serial processing, right? What is serial processing? We are processing one after the other, right? If you are having the single processor, then you need to go to the serial processing only, right? So instead of serial processing, we are going for the parallel processing here. Understood? So here earlier we used to work only on the structured data. Here in the distributed environment, we can solve the problem of different types of data. So if you see here, what are the various big data tools are available, right? So these are the various open source big data tools are available, right? Understood. So if you see here, we are having the machine learning tools. We are having various frameworks. We are having various data access tools, right? So we are having various query tools, coordination tools, real-time tools, statistical tools, right? So all these tools are open source. Only thing is you should have the interest, right? So you are in a BTech, right? You are a BTech student, right? Means what? You are a Bachelor of Technology, right? What does it mean? You have to develop some technology, right? Understood. You should not completely depend on the faculty, right? So there are a number of resources are available, right? So you should make use of the resources and you should improve your skill set. If you don't improve your skill set, the companies will not recruit you. And if they recruit also by doing something, then they will lay off within 1 year. Understood. So you have to improvise your skill set. You should have the interest to learn some new concept, right? They will not see your CGPA, right? You should have minimum CGPA, and what the companies will require, what exactly they are looking at. They are looking at the how much interest that you are having to learn the new concepts. Understood. What are your analytical skill, what are your thinking capability skills, what are your problem solving skills, right? You have to improvise these skills, right? It will come through practice only, right? Understood. So it is a kind of data center, right? Understood. It is a kind of data center, right? What exactly data center contains? It contains various nodes, right? What is this one? These are racks, right? This is a rack. Like that we are having n number of racks. Understood. So what exactly these racks contains? These are the nodes, right? Each rack contains around 150 to 200 nodes. How these nodes will communicate? How these nodes will communicate? How these nodes will communicate? They have to communicate, right? How they will communicate? Suppose you would like to connect two nodes, right? How will connect two or more than two nodes? What do you require? You require a switch, right? You require a switch that will connect to various nodes, right? Similarly here we are having a rack switch, right? This rack switch will connect to all the nodes in this rack, right? Similarly, every rack will have a rack switch, right? So here you will have some core switch. Understood. Where this, because within the rack you can communicate using this rack switch, right? But these two these two racks, how the nodes in these two racks will communicate? If they want to communicate, they should have some core switch, right? So here it will have the core switch and they will communicate among themselves. Understood. So like this, we are having various racks and group of racks, right? The data center will contain the structure like this. Understood. So, do you know about Hadoop? What is Hadoop? Huh? So we are discussing about big data, right? We are discussing about big data, right? Hadoop is one of the solution for the big data, right? Understood. So like that, we are having various open source platforms. Hadoop is one of the open source platform where we can build the cluster. Understood. So we'll discuss about Hadoop. What is the history of Hadoop, right? Do you know dog cutting? Who is this fellow? So actually, he is working in Yahoo, right? This fellow is working in the Yahoo. He read the white papers. The Google has published some white papers called Google File System and MapReduce in 2004, right? He read those papers because what is the meaning of white papers? They will not describe about the how they have implemented. They will just explain about their architecture, right? Understood. So he read those papers and he has working in the Yahoo, right? And he has extended that Apache Nudge project and he extended that to Hadoop. Understood. So whatever the Hadoop that we will learn, the basic framework we got from the Google, right? Understood. So why we need to study Hadoop, right? What advantage that you will get as a programmer? You are a programmer, right? What kind of advantage that you will get as a programmer? You don't need to worry about where the files have been located, right? So you are having, suppose you are having a 100 node cluster, right? So when you are distributing the your data, right, you are having 1 terabyte of data. You are just what you will do, you just upload the data into the SDFS, right? The SDFS will, the master node will distribute the data blocks into the cluster, right? As a user, you don't need to worry about where that those files have been located in the cluster. Understood? And you no need to worry about if there, suppose there will be some failures, right, in the data in the cluster. Obviously the failures will occur. So as a programmer, you don't need to worry about the failures. Understood? That we'll discuss why you don't need to worry about the failures, right? And you don't need to worry about how the computation have been done, right? Suppose you will write a logic, right, and that logic will be distributed. That we'll discuss in the map reduce. So as a programmer, you don't need to worry about all those stuff, right? So as a programmer, you need to worry about only, you need to load the data and you need to write the logic, the mapper logic and the reducer logic. Other stuff, everything will be taken care by the Hadoop framework. So you don't need to worry about the scaling also, right? So in traditional approaches, if you want to scale, right, you need to write a separate program for scaling the your cluster, right? But here there is no need of there is no need of for you writing explicit programs for scaling the nodes. So who is using the Hadoop? If you see here, you take these are only few companies, right? So which have been listed, right? There are n number of companies. There are a number of companies which have been using the Hadoop cluster, right? What are they? So if you see, if you name here, there are a number of companies which are using the Hadoop. So what are the Hadoop common distributions, right? So here, if you see here, here it is only here. Someone can switch off that. If you see here, what are the common Hadoop distributions? If you want to go for commercial editions, right? You are having the various commercial editions, right? Cloudera, Hortonworks, Mapper, MapReduce, Microsoft Azure, right? These are the various commercial versions of the Hadoop, and we are also having the open source Apache Hadoop version. In the afternoon session, we will see how we are going to set up the Hadoop cluster. Understood? I will provide you the documentation. If you follow the documentation step by step, then you can easily set up the Hadoop cluster in your system. What are the main what are the main characteristics of the Hadoop? The first one is the scalable, right? So it can scalable to up to 3000 nodes, right? Understood? It can be, you can have 2 nodes to 200 or 2000 or 20,000 nodes. It can be scalable up to maximum number of nodes, right? And what is the second one? The data is reliable. What does it mean? What is the meaning of reliable? What is the meaning of reliability? So because if you see here, we are following some concept, right, in the SDFS, right? So we are having the replica of the data, right? If you lose some data, right, still you find that data in some other machine. Suppose the particular machine has been failed, still you will find that particular data in some other machine. So we'll discuss that later. So in the Hadoop, we are having the reliability in terms of data as well as in terms of the machine. So why it is economical? Why it is economical? Because we are not here, we are not using any high end machines, right? Here we are using the low end machines to set up our Hadoop cluster. So this is the Hadoop ecosystem that we are having, right? So at the base, if you see here, we are having the Hadoop distributed file system. Okay. Then Yarn is the resource manager, where suppose you are having a 1000 node cluster, right? So we should have a resource manager which can manage all the resources of different users, right? That can be done by the Yarn framework, right? Understood? Then you are having the MapReduce here. We are having the MapReduce and we are having the Spark, right? So if you want to do in-memory processing, right? Understood? If you want to do in-memory processing, then you can go for the Apache Spark. If you want to have Hive, right? You can have the Hive, you can have the streaming data using the Kafka and Storm. And if you want to use machine learning libraries, if you want to do some machine learning projects on top of the Hadoop, right? For that, they are having the libraries, right? The library is called Mahout. The Mahout and Spark machine learning libraries you have. You are having various libraries, and for scripting you are having Fig, and for so if you want to work on the NoSQL database, right, then the HBase is available, right? So here I mean to say that if you want to work on any kind of platform, the Hadoop will provide all different kinds of platforms. If you have the Hadoop as a base, then you can have various different types of platforms for different use cases. Based on your requirement, you can work on that particular skill set. So for time being, we will work on the SDFS, MapReduce, and YARN. If time permits, we'll discuss about the Spark. Okay. So what is Hadoop? What is Hadoop? Why we are discussing about Hadoop? Because we are having big data. So when you are having the big data, what is the problem that you will get? How you are going to store this big data, right? And then how you are going to process big data, right? And how you are going to analyze this big data, right? Understood? So we are having various components in the Hadoop framework. We are having various components for each of them, right? What is the first component? This is the first component, right? That is Hadoop distributed file system, right? SDFS, right? So if you see, you are having your local machines, local nodes, right? What kind of file system you will have in your local machine? The operating system will maintain the file system, right? The FAT32 or NTFS or extension 3, extension 4, right? You know about these file systems. I will study the operating system. You studied, na? So in that file system is there, right? Various operating system will use various file systems, right? Those are standalone systems, right? If you see here, am I audible? So if you see here, we are having Hadoop distributed file system, right? Because you are working in a distributed environment, right? When you are working in a distributed environment, you require the distributed file system. Since it is developed by the Hadoop, so it is called Hadoop distributed file system. Next, we are having the once why this SDFS is used to store the data, right? Once you are having the data which is stored in the SDFS, now you need to process the data, right? Who will process the data? Who will process the data? For that, for processing the data, you need some framework, right? That framework we will call it as the MapReduce, right? If you see here, we are having the Hadoop MapReduce framework, right? So next we are having the Hadoop yarn, right? Suppose if you are having the 100 or 200 node cluster, then the previous version of the Hadoop is sufficient. But if you are having more than 100 or 200 nodes of the cluster, then you need to go for the yarn cluster, right? What is the yarn cluster here? It will mostly think about how you are going to manage the resources in the cluster. Understood? This is the typical Hadoop cluster that we have discussed. So what exactly the Hadoop cluster will have? If you see here, we are having various racks, right? Here we are having various racks. We are having various nodes here, and for each rack, you will be having the rack switch, right? These nodes will communicate within the rack using the rack switch, right? And off the rack, right? So if these two nodes wants to communicate, then how they will communicate? They will communicate using the core switch. Understood? So this is the typical Hadoop cluster that we are having, right? So that we discussed earlier. So these are the racks that we have, and the group of racks we are having. This we can treat as the complete data center. So if you see here you try to understand, right? Uh, for you know what kind of architecture that it will follow. The Hadoop follows the master slave architecture, right? What is the master node? What is the master? What is the meaning of master node here? What is the meaning of master node? So you are doing some banking transactions, right? Everyone is having some social media accounts, right? So whatever you are having, it is the front end, right? Understood? Whatever you are having, that is the front end, right? Whatever the images or video or whatever the data that you are processing, that is not done at the front end, right? At the server it will be done, right? At the server, the master node, the everything will be done at the master node, right? Understood? Similarly here, in the Hadoop distributed file system, what is the master node? The name node is the master node, right? In the HDFS, name node is the master node and the data nodes are the client nodes or slave nodes, right? Whereas for the MapReduce, the job tracker is the master node and task trackers are the slave nodes. We'll discuss all these nodes in detail, right? So first we'll discuss about the Hadoop distributed file system. Okay. So why we require HDFS? Suppose if assume that here we are having 1 TB of the data, right? See here, we are having 1 TB of data and you are having only one machine, right? What exactly this machine contains? What it contains? It contains 4 processors, right? It is a quad core processor and it is having L1 cache, right? Each processor will have the cache memory, right? It is having the L1 cache. So all these are interconnected to the L2 cache. Understood? So all this will be interconnected to the main memory and this is a secondary memory, right? So this main memory and secondary memory, how the communication will be done? There is a IO channels will be there, right? If you see, there is a bus, right? Have you seen that channels from main memory to the secondary memory through motherboard? It will be done, right? If you see here, so there are 100 megabytes per second IO channels are there, right? Understood? So if you want to process, this is my system configuration, right? This is my system configuration. If I want to process this data in this system, how much time it will take? How much time it will take? Just to store the data, right? Just to store this data in this system, how much time it will take? It will take approximately, am I, listen, how much time it will take to process, how much time it will take to store the data? 3 hours, right? Just to store the data itself, it will take 3 hours, right? Then when you will process the data, right? Understood? So if you see here, we are having 1 TB of data, right? Same data set we are having. What exactly we are doing here? We are splitting the data, right? Understood? Instead of storing the complete data to the hard disk, what exactly we are doing? We are splitting the data into set of blocks, right? And then we are having, if you see here, we are having only one machine. Means we are having only one processor in this machine, right? We are having a single processor. Like that, we are having 100 machines. Understood? Like that, we are having 100 machines. Can you tell me how much time it will take to load the data? In the earlier case, it took around 3 hours to load the data where we are having the quad core processor, right? Here, how much time it will take to load the data? How much time it will take? Because here you are loading the data, here we are distributing the data, right? You are splitting the data and we are distributing the data, right? Understood? So how much time it will take? Approximately 3 minutes to load the data. Understood? So what are the features of data? Means why we are studying about the HDFS, right? What is the first feature? It provides the distributed storage, right? It provides the distributed storage and it will be implemented as we discussed. The machine that we are using in the cluster, those are of commodity hardware, right? So it is less expensive, right? And it provides the data security and it is highly fault tolerant, right? Because we are following the replication policy, right? Our data is our data is having replicated across the nodes in the cluster, right? That's why it is fault tolerant. This we will discuss later. So if you see here, it is following the master slave architecture, right? What is the master node here? Master node is the name node in the HDFS, and the these slave nodes are the data nodes. Okay. What this name node will do? What is the role of this name node? What is the role of this name node? What exactly it is doing? The name node will not store any data, right? The name node will just store the metadata. What is metadata? What is the meaning of metadata? Yes, data about data, but what does it mean? What is the meaning of data about data? So, if you are going for a placement, if you say that it is data about data, he will kick you out, right? You should know, na? You should know exactly what you should know the meaning of the metadata, right? So it will what exactly it is storing here? It will have the complete information about the other data nodes, right? We will discuss this later. You will understand thoroughly, right? So it knows the complete information about the data nodes which are present in the cluster, right? So what this data node will do? What this data node will do? The data node has the exact data, means where exactly will store the data. Will store the data in the data nodes, not in the name node, right? Will store the data in the data nodes, which is the slave node here. Understood? We'll discuss secondary name node later. If you see here, this is the cluster architecture, right? This is a multi-node Hadoop cluster that we have discussed earlier. We are having the name node, we are having the secondary name node. If this name node has been failed, then it will go to the secondary name node. And here these nodes will communicate using the core switch, and we are having various data nodes. Understood? We are having various number of data nodes. With assume that these are the racks. Okay. So what is the role of name node here? As I said, it stores the metadata, right? Name node is the master node. It stores the metadata. So what does it mean? What exactly it will store? What exactly it will store? It will store the information about the data node. Means what? How much space is available on this particular data node? Because assume that you are having 1,000 data nodes, right? The 1,000 data nodes information is available on the name node. How much space is available in each and every data node, and what is the replication factor that they are following, and which node has been failed, which node has been active. All such kind of information is available in the name node. And here we are having the data nodes, right, where exactly the data is being stored. How this data node and name node will communicate? How they will communicate? They will communicate using heartbeat messages, right? So here if you see that name node will not communicate to the data node. The data node will communicate to the name node using the heartbeat messages. The internal mechanism is the remote procedure calls, right? Have you studied about RPC? Remote procedure calls. So here they follow remote procedure calls, right? So they will send the information to the name node. Based on the information that they have sent, the name node will distribute the data blocks to the data nodes in the cluster. So assume that we are having a file one. It is of some size, right? It will be divided into some blocks. Assume that the block size is 128 MB. This file is divided into 128 MB blocks. Each block size is 128 MB, and this name node is distributing these blocks across the nodes in the cluster, right? And they are following the replication factor. If you see here, the block one is stored in this name node, this data node. This block is stored here. This block is stored here, right? So we are having the redundant data blocks, right? Why we are having the redundant data blocks? That we'll discuss later, right? So if this machine fails, right, still you need to the data should be available in other node, right? Understood? Because in our case, the data is uh, the data is having the higher priority. Understood? Suppose we are having the 530 MB data. So this 530 MB data is distributed across the nodes. It will be 128 MB. So it is having 5 blocks. Understood? Suppose this node has been failed, right? Suppose if this node has been failed, what will happen? What will happen if this node has been failed? You will lose this information, right? You will lose this information, right? Then what is the solution? What is the solution? What is the solution? As I said, we are replicating this data block, right? We are replicating this data block to this machine, this block to another machine. Here the replication factor is 3, right? Understood? So we are replicating the data blocks. Suppose this machine has been failed, right? The node 5 has been failed. How many blocks this node 5 contains? The node 5 contains block B, block D, and block E, right? It contains 3 blocks. We are losing these 3 blocks, right? So whether we are losing exactly these 3 blocks. So here we are following the block B present in some other data node also, right? This node the block B contains, right? And block D contains in node 1, right? Block E also contains in some other, here the block E contains, right? Understood? If we lose this node 5 also, if this node 5 failed also, we can able to extract the data. Understood? So what exactly we are saying here? What exactly we are discussing here? Because in the Hadoop cluster, because you are having thousands of nodes, sometimes the node failure is common, right? When the node failure is common, you should not lose the data, right? So that's why we are going for the replication factor. We are having the redundant data in the cluster. So if you lose this machine, we are having the different, these data blocks are present in different nodes. So if you see here, we are having the core switch. This one is already discussed. What is the replica placement policy, right? So we have discussed that we are having the redundant data, right? Redundant blocks we are having. We cannot place the redundant data as you like, right? So there is a policy that is called replica placement policy. What is the first policy? No data node contains more than one replica, right? So what does it mean? Each data node should contain only one replica of the block, right? Why? If you contain more than one replica, what will happen? If that particular data node has been failed, right? If that particular data node has been failed, you will lose the data, right? So that's why in a node, you should not have more than one replica of the block. What is the second rule? What is the second rule? No rack should not contain more than two replicas of the same data block, right? Why? Why we are following that policy? Why we are following that policy? Suppose your rack also may fail, right? Suppose sometimes your rack switch may fail. If your rack switch may fail, then the nodes within the rack may not communicate, right? You will lose the complete data which is present in the rack, right? So in order to avoid that one, you should not have more than two replicas within the rack, right? If the rack failed, then at least you should have one replica and other because our replication factor is 3, right? So data node should not contain more than one replica. The rack should not contain more than two replicas. Understood? So that our data is secure. If you see here, we are having block A in rack 1 of data node 1, and we are having block A in rack 2, right? We should not have more than 2 here, right? Understood? If that particular rack has been failed, right? If this rack has been failed, then you will unable to fetch the data if you don't follow the replication factor, right? Here we are following the replication factor. So we will follow the replication factor through rack awareness, right? So if you see here, name node is following the metadata information, right? What exactly the metadata contains here? It contains the rack awareness. In a rack, how many data nodes are present, and each data node, in each data node, how many data blocks are there, right? And suppose block A is there, the replication factor is 3, right? And here the block A is present in various data node 1, 5, 6. Similarly, block B is present 7, 1, 2, right? So it knows all this information, right? When it knows all these kinds of information, then if this rack has been failed, when you are running a program, right? You will run some program, right? When you are running a program, if this rack has been failed, then it will fetch the data from various other data blocks, right? Understood? So if a particular node fails, then if a particular node fails in the rack switch, then we can solve this problem using the rack awareness replica placement policy, right? Understood? If a particular rack fails, right? If a particular rack fails, still we'll have one replica of the block in some other data nodes in the cluster, right? Understood? So everything will be done with the help of what? Name node, right? because name node maintains all the rack awareness and the metadata information. What will happen if that particular name node fails? Name node also sometimes may fail, right? What will happen if that name node fails? What will happen? Because name node doesn't contain any data, but you cannot communicate to the data node directly. You can communicate to the data node through name node, right? Understood? If name node fails, then you cannot communicate to any of the data nodes in the cluster, right? So name node is a single point of failure, right? So in order to avoid that one, we are having secondary name node. Okay, we are having the secondary name node. We'll discuss the secondary name node after the break. We can have break, na? So my request is, whoever is interested, only those students can come. If you are not interested, please don't come. I request your management to give attendance or whatever they might have said. So don't come for the attendance sake. If you are really interested, come. Otherwise, don't.